Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on sets. So a set is just a collection of objects. We could have the set of people who play soccer, the set of prime numbers, whatever, just a collection of things. But when we're talking probability, we're usually interested in a set of events. So we're going to use this letter here, Greek letter epsilon, to denote the universal set. So for this example, we're going to let epsilon, the universal set, be the set of integers 1 to 30 inclusive. Inclusive means 1 is part of the set, and so is 30. So to write epsilon, to write the elements that are in epsilon, what we do is we use these squiggly brackets. So these squiggly brackets in maths denote a set. So here we have a set of numbers. Integers means whole numbers, 1 to 30 inclusive. So epsilon would be the set. 1, 2, 3. I don't want to write all of them, so I'll just put some dots in all the way up to 30. So let's say I now pick a random number between and including 1 and 30. So random, straight away you should be thinking, okay, this is something to do with probability. So if I pick a random number between and including 1 and 30, suddenly epsilon here becomes a set of events. This is the event that the number I pick is 1. This is the event the number I pick is 2. This is an event, the number I pick is 3, and so on. There are 30 possible events. So we're going to define two subsets of epsilon. So we're going to let A be the event that I pick a multiple of 4 and B be the event that I pick a multiple of 3. So A and B are actually sets. They are lists of possible outcomes. So to write A, I need to use these squiggly brackets because it's a set. So if I pick a multiple of 4, I could pick a 4. That's one possible outcome. I could pick an 8, a 12, a 16, and so on. So I'm going to stop at 28 because remember I'm only picking a random number between including 1 and 30. So similarly, I could write B. And I again use squiggly brackets because B is a set of outcomes. So if you see this, something written like this, this means the number of elements that are in set A. So A is a set. Each of these things that makes up A is called an element. So you can see there are 7 elements in A. So we write, this is the number in A is 7. Similarly, the number in B, if you count how many are in B, is 10. So what about this? This little dash here means not. So if I write something like this, this says the number that are not in A. So we're only looking at numbers between 1 to 30 inclusive because that's what our universal set is. So if there are 7 of these 30 numbers are multiples of 4, the number that are not multiples of 4 is 23 because we're only looking at integers 1 to 30 inclusive. So there's a few other symbols we need to know. So the first is when we look at something like this. So this little N here, the way you read it is AND. This here means A and B. So A and B is itself a set. It's another set. And it includes all of the elements that are in A and also in B. Only the ones that are in both. So let's go ahead and look at which of these numbers would be in A and B. Well, we can't put 4 in there. 4 is in A, but it's not in B. We're only looking for ones that are in both. So the ones that are in both are 12, that's in both, and 24. So A and B is the set, that's why I'm using the squiggly brackets, containing just 12 and 24, because these are the two numbers in both. So once again, I don't include number like 15, because it's not in both, it's only in one of them. So of course, if I wrote something like this, this means the number in A and B that would just be 2, because there are only 2 elements in this set. So if I have something written like this time it looks like a U, it means union. You read this symbol as OR, A or B. So once again, A or B is another set, but this time we're including all the elements in A, all the elements in B, and any that occur in both. So all of these elements here are in A or B. So we include 3 in this set because it's in B. We include 4 because it's in A. But see, a number like 5, well, 5 is not in either of these sets. So that's why I don't include 5 in A or B. So A or B includes all of these numbers and all of these numbers. And so you can see that there's always more in A or B than there are in A and B. So that's really all there is to it. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.